Alright, so now we're going to look at the special angle coordinates on the unit circle. So we know and love the degrees and radians all around the unit circle for these special angles. Well, what are the locations of the coordinates on the actual circle? That's what we're going to look at. So we're looking at points, x, y values. Well, how do we know what the coordinates are on the unit circle? It should be relatively straightforward because we know the angles. So let's think about this for a second. If we focus on the first quadrant, because if we know the first quadrant, then we can know everything else because of, very good, reference angles. So if I look at the first angle here, and we're going to do this in degrees, just because it's easier to think about. And I draw this right triangle. Okay, well, it's a 30, 60, 90 triangle because I know this is 30 and this is 60. And I know my 30, 60, 90 triangle is x root 3 and 2x. But what else do I know about the unit circle? And hold on a sec, let me back up for 1 minute. What we're looking for are the coordinates of this point right here. So we want to know the x and y coordinates of this point. Well, the x and y coordinates are going to be... Okay, so that's what our 30, 60, 90 triangle looks like. But let's do something else real quick. So here I just cut out a little bit of the first quadrant on a graph. And if I plot this point right here, 5, 2. So I know this is the point 5, 2, but we want to make sure we understand where does that come from. Well, if I draw a right triangle for this, or I should say, how does this point relate to a right triangle? If I draw a right triangle from the origin, this side right here is 5, and this side right here is 2. So this gives me my x value, and this gives me my y value. Now the reason why I point that out is because the same thing is going to happen here. So to avoid confusion, I'm actually going to change variables here. Apologize for that. You already wrote things down. So instead of calling this x, let's call it something else. Let's call it z. So this is z root 3, and this is 2z. So how does this help? Well, what do we know about the unit circle? What makes it called the unit circle? Remember, the radius equals 1. That means the hypotenuse here is 1. So if I know that 2z equals 1, then I know z equals 1/2. So in my coordinates, the y value here is going to be 1/2, and the x value is going to be 1/2 times the square root of 3, or root 3 over 2. Now, the same thing can be done for the 45-degree angle and the 60-degree angle. In fact, I can see from the 30, 60, 90 triangle that I have drawn here that if I switch the 30 and the 60 degrees to draw in this triangle, that these two values are just going to switch locations. So at 60 degrees, the coordinates are going to be 1/2, comma, root 3 over 2. Well, what about at 45 degrees? Well, if I think about my 45, 45, 90 triangle, then I can call this side Z, and this side Z root 2. But again, I know Z root 2 is 1, so Z equals 1 over root 2 or root 2 over 2. So I know here, and that is going to be true for both the x and y value, because both of those are z in this case, because it's a 45, 45, 90 triangle. Now don't forget we also want to label the coordinate angles, so this is going to be the point 1, 0, and this will be the point 0, 1. Now, once you have the first the first quadrant labeled, then the rest is easy, because you know that they all have all of the angles have the same reference angles as the first quadrant. Therefore, they would all have the same triangle if you drew in a triangle. So, for example, if I draw this triangle, this is 30, this is 60, and this is 90. The only thing that's going to change is in the second quadrant, the x value is negative and the y value is positive. So I want you to go ahead and label the rest of the coordinates around the unit circle. So pause the video and do that. The only thing you have to be careful about is making sure that you have the correct sign, positive or negative, in the correct location. Pause the video, unpause when you're ready to check your work. Try not to cheat by looking at the example on your page. Okay, so the unit circle with all the coordinates should be these values, 1, 0. We already did the first quadrant. Second quadrant at 120 degrees or 2 pi thirds is negative 1/2 root 3 over 2. At 135 degrees or 3 pi fourths is negative root 2 over 2 root 2 over 2. Here we have negative root 3 over 2 1/2. And at pi or 180 is negative 1 comma 0. As we move to the third and fourth quadrant, we can see that at a given reference angle, so pi 6/30 degrees, I have a root 3 over 2 and a 1/2, but in the third quadrant they are both negative. Here negative root 2 over 2, negative root 2 over 2, negative 1/2, negative root 3 over 2. At 3 pi halves I'm at 0, negative 1. At 5 pi thirds, 1/2 comma negative root 3 over 2. At 7 pi fourths, root 2 over 2, negative root 2 over 2. And at 11 pi 6, root 3 over 2, comma negative 1/2. So then here is the entire unit circle with all of the angles, all of the coordinates in both radians and degrees. You will have a quiz where you will have to fill in all of this information. You will have that quiz before you move on to the next unit. However, once you take that quiz, you will be allowed to use the unit circle. You'll be given one on every assessment from here on out, including the final. Okay, so then how does the unit circle relate to sine, cosine, tangent, cosecant, secant, and cotangent? And now pay attention to the fact that we're specifically talking about the unit circle. So the radius is 1. This is going to change slightly if we were dealing with any circle, which we can, but it doesn't change a lot. So let's talk about sine real quick. I know sine of theta is opposite over hypotenuse. But I know that any triangle I draw on the unit circle has a hypotenuse of 1. So when I say sine of theta is opposite over hypotenuse, the sine of theta is really just the opposite, because it's opposite over 1. And so if I think about that first thing here with my 30, 60, 90 triangle, the opposite was 1/2, which turned out to be the y value. So when we're talking about sine on the unit circle, sine is going to equal the y value. Cosine was adjacent over hypotenuse, but again, the hypotenuse is 1, and here the adjacent was the x value. So the cosine of theta is going to always equal the x value of the coordinate on the unit circle. That's what we're referring to. Tangent of theta is opposite over adjacent, so therefore it is going to be y value over x value. And then the reciprocal functions are the reciprocals of these. So cosecant theta is 1 over the y value, because the hypotenuse is 1. If the hypotenuse was, or if the radius was something else, then this number would change, but it's still going to be over the y value. That's important to recognize. Secant of theta is 1 over the x value. And cotangent of theta is x value over y value. Alright, so it's very important that we know the coordinates on the unit circle. Again, these special angles come up so often, and we use the unit circle so often that just knowing what they are can save us a ton of time. We don't want to have to draw a triangle every single time to figure out what the x value is or what the y value is. In a crunch, you can do that. We also want to know that if we have the unit circle, how to use it. So again, you'll have to memorize it for a quiz, but after that quiz you'll have a sheet that you get to use. But if you don't know how to use it, it's really no use to you. A tool is only as good as its operator.